My name is Răzvan Crainea. I'm with the OpenSIPS project, and today we will be talking about VoLTE and WebRTC using OpenSIPS. This is the outline of my talk, but let's go through it. A few things about me. I'm from Bucharest, from Romania. I joined the OpenSIPS project 14 years now, so in 2010. Throughout the years, I became one of the OpenSIPS core developers, and currently I'm also the CTO of SIPA, which is a company that provides different solutions based on OpenSIPS. And when all I do with my time, with my remaining time, is spend it with my 3 years old kid back home. About OpenSIPS, for those who don't know what it is, it's an open source SIP proxy or server, which is very flexible. It has more than 170 modules right now. It is highly programmable, highly scalable, can support more than 20K calls, millions of simultaneous calls per second, and mainly we have that much simultaneous calls because we don't actually go into the path of the media. We usually offload media to other media proxies such as RTP proxy, RTP engine, media proxy, and hopefully soon Janus using the NoSIP plugin. OpenSIPS can be used in various use cases, from SBC, trunking solution, residential, virtual PBX, front-end for your existing SIP infrastructure, load balancing, whatever. As I said, it is highly programmable, so you can do whatever you want with it. You just tell it how to handle the SIP messages you receive, and he will do all the work from you. And IMS is one of the applications that can be implemented using OpenSIPS. For those of you who don't know what IMS is, I'm going to describe it in, let's call it, simple terms. First, it stands from IP Multimedia Subsystem. And essentially, it starts from a 3G or 5G, 4G network that is offered by one operator. So probably all of you have smartphones that run 3G or 5G or 4G network. But the idea is that the operator essentially only offers the IP connectivity. You can also provide some sort of calls, but those are running through GSM, so they're not running over IP, which has a few limitations that we will see afterwards. But again, it all starts with an operator, which pays a lot of money to build different towers that users pay for them to use. So basically, a user goes to the operator, gets a subscription, which is stored in the database that we see inside the operator's network. And then it is able to register, gets a SIM card, puts it in or eSIM card, puts it in his phone or configures it in its phone, uses the tower to connect to the operator network. So as you can see right now, the endpoint has IP connectivity. So basically it can browse the internet. Now, of course, in order to place calls, it can use the legacy, let's call it, legacy infrastructure that uses packets to switch packet to place calls. But you can also benefit from this IP layer and provide, for example, voice or video calls through third-party applications. I don't know. There are a lot of providers for residential solutions. However, you would also, actually what IMS is, it describes how you can add voice or video applications on top of this 3 or 4G network. Basically, this is the purpose of IMS. It's actually an architecture framework which basically describes all the components that need to be placed and what are the interactions between them, how they can communicate, what kind of what protocols they use, what kind of messages they can exchange, and so on and so forth. It's highly modular. There are multiple components. Each of them have open interfaces. This means that you can always, for example, if one of your component doesn't behave, you can take it out and replace it with, I don't know, for example, an open source solution. It might be OpenSIPS, it might be something else, for example, RTP engine for media gatewaying, or PyHSS for the HSS database, whatever. It is open, everyone, as long as a component implements the interface, the public standards, it can be done. This is how VoLTE, this is actually what VoLTE is an application on top of IMS, which probably you've all heard about VoLTE. It's voice over LTE. LTE stands for long-term evolution, or and it has been developed in 2000, or written in 2009, adopted in 2010, and it was quickly adopted. As you can see, starting with 2012, there was the first release for operators, and quickly escalated to 2029 operators and to 2020. So this shows how important for operators is this kind of VoLTE, right? The ability to route calls over IP instead of packet switched networks. And mainly because it brings a lot of improvements over 3G or 2G networks, such as fast call setups. You have lower delays and low latency on 4G networks. High definition voice quality. So basically you can make calls with different or better codecs than GSM. You can also have video calling, whereas in traditional phone systems, you don't have it. And you can do all sort of, for example, reduce background noise because you have lower latencies. This is the VoLTE, like a glimpse of the VoLTE network architecture. So on the left side, you have the user equipment, which is your phone, connects to a tower, and the tower goes directly into the core network, which is the center of our slide. And on the lower side is the old packet switched way of doing calls. On the upper side, as you can see, is the IMS core, which is the new way of the VoLTE way of of placing calls. Of course, you still need to interconnect between those for compatibility issues. For example, if you have users that do have 4G but others don't, you still need to implement the whole, the entire architecture. But things have evolved. So specifications were done in 2010, then adopted in 2012, and probably you all know, starting with 2020, 5G appeared, and it has spread it quickly again due to low bandwidth to its speeds. It also, due to the low latency, you can also provide better codec support. This means faster call setup, better calls quality, better video quality. However, it also allows to fall back to VoLTE. So 5G, due to its at least initial coverage, is not that good. Therefore, as for example, Tim said, you will always find a better 4G network, or you might find a better 4G network or there are cases where 4G networks are better than 5G. So you need to be able to switch between them. The specifications do provide this support. However, they don't provide support for 3G or 2G fallback. So you can move a call, an ongoing call, from 5G to 2G or 3G, only to a 4G network. This is one of the architecture that voice over new radio or voice over 5G looks like. On the lower side of the picture, we have the architecture of the old architecture of the 4G networks. On the upper side, we have the architecture of the 5G networks. But as you can see, the IMS is more or less the same. So the structure or the architecture of the IMS doesn't change that much. It does change a few protocols that we will be talking in the next slide, but the structure itself, it's the same. Oops. Uh, Basically, the difference between them are different core architecture. However, the IMS is the same. They use different interfaces, although 5G also supports diameter interfaces, at least one solution. There are solutions that require or promote the use of HTTP 2.0, which is the service-based interface described by the 3GPP guys, um, and they claim actually they say it's better, it has lower latency, it's better adapted, and so on. So they prefer this new HTTP 2.0 interfaces to the diameter one. This is how fallback between voice over new radio and OLT looks like, and we're not getting into it. The idea is there are a lot of flows that need to be implemented, a lot of requests for a call to be established, for a call to fall back. But the idea is the IMS is more or less the same. Besides having the two different protocols for querying the databases, they are more or less the same. In terms of architecture, this is a 4G network architecture. I will only present it, I will only give it as an example. I'm not getting into too much details. You have different layers. The transport layer offers the 4G or 5G connectivity. The control layer tells you how the packets can be switched. For example, again, how Tim said, in his case, he had a VPN between the towers and the core network, so they don't necessarily need to be located. Actually, you have multiple towers and one single core. Well, you can have more core as well, but it depends on how you want your architecture to be. But the idea is that the core network is the one that has the logic. In terms of IMS, it relies on CSCF component, which is called service control function, I believe. Um, and it uses several protocols, SIP, which OpenSIPS already knows, diameter, which OpenSIPS knows, MSRP, SDP, RTP, RTCP, XCAP, and finally with the new architecture, it also needs to know HTTP 2.0. Getting a bit into it, proxy CSCF, it's basically a SIP proxy. It's the main entry into the IMS core. Once the user equipment gets an IP, it sends directly a SIP message, a register message to the proxies. Basically, it acts as a dummy SBC. Its purpose is to create a secure channel between the cores of the network and the phone itself, and enforce that security. There's also interrogating CSCF, which is also a SIP proxy, and it handles SIP transaction, and it's being used for more or less as a load balancer towards the actual core component of the IMS core. Which is the serving CSCF. It is the central node. Of course, it can be distributed as well due to the modular architecture. But this is the so-called brain of your platform. This is where the users are registered. This is where who knows how how calls should be routed, either to a different call, either to a service, and so on and so forth. It does authentication. It interrogates the main database about what are the configured users, what are the subscribers, what are their profiles, and so on. HSS is actually the main database. This is in 4G. It's basically a diameter server with persistent storage. That's where all your users are being stored and as well as their profiles. And the service layer is an extra layer that is above, so it's outside of the control layer. And basically here you have all the value-added services you want to add for your users. I don't know, I would say voicemail, but voicemail is actually part of the core. So I don't know if you want to offer, let's say, call centers, that's where they would, that's where the call center solution would stay. In terms of implementation, PSCF, as I said, its main purpose is to provide a secure channel between the user and the core network. It uses the RFC 3329, which is Security Mechanism Agreement, to enforce all sorts of security profiles. And of course, in a call, we have two different layers. It's signaling, which is ensured through IPsec tunnels and AKA V1 authentication methods, or TLS using trusted certificates and AKV2 authentication. So this is for signaling. For media, which is has a different path, it has to use SDES and DTLS SRTP if you're using if you're communicating over RTP. It has to use TLS if you're doing MSRP, or TLS and certificates validation if you're doing UDPTL or BFCP. So all of these are already supported and uh, strictly controlled by the IMS specification. As I said, OpenSIPS is able to perform all of these functionalities for both proxy interrogating serving calls. That's because it already is a SIP server, so it has a SIP interface. So it by default implements the GM and MW interface. It also has diameter support, so we added custom handling for CX, DX, and RX interfaces, the ones that we need to for VoLTE. And we've recently added IMS, aka authentication, in order to support authenticating user through this method. Although the specification allow lower, let's say, digest using trusted IP authentication, most of the users don't really allow that. OpenSIPS can also act as a voice over new radio, PSCF, sorry, PCSCF, apologies for, again, because it does SIP signaling, and we've recently added HTTP 2.0 implementation for a service-based interface described in 5G specification. So I've presented you the core and how IMS, what IMS is and how IMS works, but we're in a WebRTC conference. So I also want to talk about WebRTC related stuff, right? This is where EPCSCF comes in. Basically, it stands for PCSCF Enhanced for WebRTC. It has been introduced actually it came with the old WebRTC FOSS around 2013, 2014, when everybody was discussing about WebRTC. And of course, the operators said, we need that. They really like the idea, we need that as well. But how do we do it? How do we make a browser go deep directly into our core system? Well, this is exactly what enhanced PCSCF does. And its goal is to provide unified, browser unified services for your customers, for the customers of the operator, and describes how you can do that. As you probably know, WebRTC doesn't enforce a signaling protocol. This means that the enhanced PCS-CF, although the PCS-CF requires SIP signaling from the user from the phone, this guy doesn't require SIP. So it can be anything. This means that even Janus can act as an enhanced PCS-CF server with a small twitch. I will tell it afterwards. That's why SIP over WebSockets is preferred. but we'll talk about this a bit later. This is the architecture. It has, again, several components. And not sure if you remember, but I don't have a pointer right now, but where the enhanced PCSCF stands, usually in traditional network, there were only regular PCSCF. Now we have the enhanced one. That is fine. The only problem is that the interrogating and the server CSCF only speak SIP, because they speak, as you see there, the MW interface, which is a SIP oriented interface. This means that although on the left side, the enhanced PCSCF can talk whatever WebRTC, on the right side, it needs to talk SIP. This is why, as I said, Janus can act as well, because it can convert whatever it receives over WebRTC, it can convert to a SIP interface. This is what OpenSIPS does as well, but this is why SIP over WebRTC is preferred. That's because when you get SIP over WebRTC, you simply dump the WebRTC stuff, the WebSockets overhead, and just send the packet towards the serving or the interrogating server as a plain SIP. Let's see how it works. So basically we have a WIC, which is a WebRTC IMS client. This is a JavaScript application that runs in a browser and can be downloaded from whatever third-party web server hosted on the operator's network, or can be anywhere as long as as long as it's trusted by the browser. You go, you download it, and use it from your browser. Now, from your this is actually what implements the logic for communicating with the enhanced PCSCF. If you're doing a SIP web or SIP over WebRTC, it will have the SIP, SIP, let's say, user agent behavior, but it can also be a Janus endpoint. As I said, it is being downloaded from a regular web server. You don't really need to do anything with this web server, so it's just a regular web server. But of course, you can limit who is able to download this WIC application. So who you offer these features to. But it's outside of the specification job. So anyone, in theory, anyone can get the WIC because it's not yet authenticated. Authentication happens way later. Enhanced PCSCF is actually a gateway between whatever protocol is talked on, is discussed between WIP and is discussed with WIP. It needs to normalize it to a SIP protocol, and also needs to ensure that there is a trusted channel between the WIC and the SBC, the enhanced PCSCF. But once this is all its job, from this point it behaves as a regular PCSCF and uses the same interfaces towards the core of the IMS. Of course, again, when we're talking about calls, we're not talking only about signaling. We also talk about media, and there are also specifications for this. We need an enhanced IMS access gateway, which is able to handle media. It needs to do all sorts of transcoding. For example, as you might know, WebRTC requires encrypted traffic. However, on the core side or on the IMS side, there's not always they're not the same specification and the same requirements. So you might need to do some sort of decryption at the edge of the IMS core. You may need to do some sort of transcoding. You also need to handle ICE, stun, turn, and make sure that your customers have access to the media. This is what the enhanced IMS access gateway does, and this is its turn. In terms of OpenSIPS, all I've listed so far can already be done. As I said, it can also be done using Janus. Why? Because we already support SIP over WebSockets. We already provide AKA authentication. We don't do anything about media, as I said at the beginning, but we can hook RTP engine or RTP proxy in order to do the DTLS conversion. So basically, it's everything in there. You just need to take them and glue them to your needs. In conclusion, I've talked a bit about what OpenSIPS is, how you can use OpenSIPS to create an IMS core, what is an IMS, and what is an EPCS-CF, and how you can use it to provide users from a browser direct access to the IMS core, which I find quite useful. Unfortunately, this hasn't got so much popularity so far. So I've actually never realized an application for it so far. However, there's one more thing I want to talk about. It's because IMS it's a mess. For those of you who've worked in IMS, they probably know that. For those of you who are about to work with IMS, you will learn about this. Everything is a mess. So that's why we are trying to do the best for it. So to this goal, we decided to create the working groups. Basically, what working groups are, it's a set of people. We're trying to gather as many people as possible, which are interested in running IMS networks, and pick their brain and gather their knowledge, their experience, their desires, how they would like to create a new network. What do they need? We do this every single time before considering any kind of development. That's why we strongly suggest it's open, everyone has access to it. So if you are willing, if you have any inputs on IMS, you can just go and subscribe on this mailing list. It's free, and any input is welcome. We surely consider them every single time we start developing something. Last but not least, as Lorenzo said, we have our own summit, which is taking place in, I think, 3 weeks from now, roughly 3 weeks, which is 2 weeks? Yeah, 2 weeks. It starts from 14th up until 17th of May. So it's 4 days of presentations, workshops, and we also have an OpenSIPS training in the last day. All of you are, if you are into telcos, it's not only OpenSIPS focus, but if you are into telcos, make sure you make it. And as I said, I have a surprise for all of you. There's a discount code for all the Janus attendance, which is available up until 5th of May. So if you guys decide to come to the OpenSIPS Summit in Valencia, Spain, you are more than welcome. Use this discount code. I will also share it on Twitter, or I will ask Lorenzo where it's better to share for all of you to get it. Thank you so much. And if you have any questions, do let me know. Thank you.
Thank you, Răzvan. And I think IMS is a mess, is a meme. I think you can make a sticker out of that.
I always say it.
Are there any questions for Răzvan?
Just throw it.
I mean, I don't know much about IMS, but I'm trying to understand from a WebRTC point of view. If you have a mobile client with WebRTC, is the expectation that the flow would be through this IMS network and not instead of an IP, internet IP?
So no, it is going to be over internet IP, but over the 4G network. So it won't go outside of the network. It will always stay there because it will always need to remain trusted.
Okay.
So, of course, there are breakthroughs from the core networks. You can go to other applications as well, but there's again similar to what it is for IMS SIP. Where is it? Here. So you have that whole, the layer about is outside of the core, and there are breakthroughs. You need to open, for every single flow, you need to open the firewall. So there are certain routes that you can do in order to access external applications as well. So this is what the specifications say, what exactly you need to do in order to access the core and what the core has to do in order to access external services.
I think I get it. Thanks.
Okay.
Any other question?
I was a bit fast.
Not
Then-
good, not as good.
Thank you so much for having me here. I hope you liked it, and I will be around for any other questions.
Thank you.
Thanks.